Let's see how we apply Coulombs law to a problem. Read the problem first. It says a young woman accumulates a charge Q sub 1 of 6 times 10 to the negative 6 coulombs while sliding out the front seat of her car. That means she, because it's positive, has lost electrons. Her boyfriend has been standing in the wind, is going to accumulate electrons, and now has a charge Q2 of a negative 2 times 10 to the negative 6 coulombs. I'm sorry that my subscripts and superscripts aren't showing up on this. This particular platform doesn't allow for that. Calculate the force between them if they are separated by 0.5 meters. Is the force attractive or repulsive? All right, we're going to do what we always do. We're going to write down our knowns and our unknowns. So the first thing I'm going to do is identify Q sub 1. And Q sub 1 is equal to 6 times 10 to the negative 6 coulombs. Q2 is equal to, and I'm going to put the negative in parentheses, and you'll see why in a little bit. 2 times 10 to the, my times is not showing up, to the negative 6 coulombs. I know that my distance between them is equal to 0.5 meters. And I'm going to label these as coulombs up here just to get you used to that unit. I know it's probably one that you're unfamiliar with. Coulomb is the standard unit for charge, and it's capital C. And the other thing that I do know is K, not because it's given in the problem, but because it's a constant. And K is 9 times 10 to the 9th newtons times meters squared all over coulombs squared. All right, now my formula, F sub Q, is equal to K, Q1, Q2, all over R squared. Now all I have to do is plug it in. So it's equal to 9 times 10 to the 9th times 6 times 10 to the negative 6 times 2 times 10 to the negative 6. Do you notice what I didn't do? I did not put the negative into the problem itself. It's not really relevant to the math of it. Remember that force is a vector, and vector is about direction. And we're going to take a look at what the direction would be after we're all done with our math. We've always done that with vectors. And it's going to be all over R squared, which is 0.5 quantity squared. And when you do the math, you're going to end up that it is 0.432, and because it's a force, it's newtons. And you see that with my units up here, the Coulomb squared is going to cancel out from what's happening on the top here, and the meter squared is going to cancel out from what's happening on the bottom. So I'm left with newtons for my answer. So that makes sense. But remember, this is a vector, and a vector has to have direction as well. Now I'm going to look at my signs on my charges. I have a positive sign with this one and a negative sign with this one. Opposite charges, so what's going to happen is this is going to be a force toward each other. And that's how you do Coulomb's law. Write down your knowns and your unknowns. It's just like any other problem. You write down your knowns and your unknowns, plug it into the formula. The only thing that you have to remember is that because it's a vector, it has to have direction to it. And you're going to identify the direction by the charges, by the signs rather, on your charges. Opposites attract, like charges repel. If you know that, then you are good to go with the rest of these problems.